Good afternoon, a warm welcome with LMT Tools here at the EMO in Hanover and parallelly live in the internet. My name is Martin Danielzik and I give you a warm welcome of the LMT Group Academy. Uwe Kretschmann at my side is the head of construction and Professor Dr. Bernhard Kapuczewski of the Institute for IFQ Magdeburg, University of Magdeburg. Today's topic with the LMT is gear cutting. The LMT said that we will present a new hub generation, SpeedCore, and we would like to tell you how we have developed it with the University of Magdeburg. Professor Kapuczewski, hubs you need to produce gear cutting and gear wheels. How many do there exist worldwide? It's an easy question, but the answer is not that easy. We have a broad overview on the situation in Germany, and in Germany per annum we are producing 200 to 250 million gear wheels, and on a worldwide market this would be more than 2,000 million, 2 billion gear wheels. For me personally, it's incredible, and I wouldn't have believed that these are dimension of billions. Gear wheels have to be produced, and what is the criteria for the production of gear wheels? We need to have tools, machinery for them, and what is important in this aspect? For the user, in the end, decisive is the quality of the produced gear wheel. That has to be the priority, and so productivity also is one important criteria in production. Quality with the gear wheel is geometry on the one hand, and on the other hand also the behavior of sound, and the last things are characterized by the productivity, and that is influenced by hobbing, because hobbing is one of the decisive processes, and in the production chain it's one of the important factors. And here I would like to pass on to the specialist, to the expert. Uwe, what is the main criteria? We know that hobbing is the most productive proceeding to produce gear wheels, and here it's important that the corresponding quality is reached and that they are durable. And with the standard hubs you can do that today, but productivity is another important term, and the pressure of costs. Here at the EMO 2011 we have a new SpeedCore generation presented, which meets these requirements. And this SpeedCore, I would say, because this cutting material is based on a higher reliability. We have bridged a gap between HMSS and carbide. With SpeedCore we have reached this aim. So we want to see it in practice, SpeedCore, and our colleagues in the University of Magdeburg at the EFU have preserved and prepared a presentation. I welcome Mr. Jäger, Mr. Naffing, and I pass on to Magdeburg. Please show us the tools at work. Thank you, Mr. Danielczyk. Here at the Institute of Production Technology and Quality Securing, Stefan Weger of LMT-FETTE is at my side, and Christian Hertling, engineer research at this institute, who will operate the machinery. Today we would like to show you the characteristics of SpeedCore in comparison to PMHSS. Thank you very much. So today we would present to you hobbing. So we have chosen a model 2.7 millimeters, that means 130 millimeters, and it has a width of 29 millimeters and an angle of 24.5 degrees. And as a tool, we have shaft tools of a diameter of 80 millimeters, and in this first presentation we will have first a conventional hop, a PMHSS with 170 meters per minute, and this corresponds more or less a thickness of 0.2. Mr. Hadling, could you please start the process? This hobbing will take 36 seconds. In practice, it has, of course, a unit to change pieces, so it needs a time of 40 seconds of processing. The LC-180, it can be used in wet production and in dry production. Here at the IFQ in Magdeburg, this machine is basically used in dry production. As Mr. Weber already said, it's a handling automatization is not existing because in research we do not need that. The process is now finishing. The next thing is that we will use a tool of SpeedCore that will take 3 minutes to change. So I pass on to Hanover in the meantime. Thank you very much, Magdeburg. That was a very efficient presentation, and we have good pictures and good sound. Thank you. So I would like to use these 3 minutes in the meantime. So please present to us your institute and the University of Magdeburg. What are you doing? Well, briefly, the IFQ is characterized by the whole reach of production proceeding. My group has to do with hobbing. We have quality securing, measuring. We care about the tool machinery, that means construction. And one of the main things is the processing of tools. We are able to produce shaft tools completely on our own until coating. So this is one of our focuses. Another focus is the gear cutting research. Here we are involved in hobbing, and our competence is involved in this institute in automobile industry, in ICAM. And here we were able to use the plant of the firm Liebherr. That means we are trying to use the whole range of proceedings in the different proceedings. So you are the perfect partner for us to make these tests. So in this project, how far have you been involved? We have a tradition in cooperation with LMT-FETTE, so we cooperated in high professional hop nanosphere tool, which is already introduced into the market, and the cutting material HSS, and as well as the carbide. And we also made an analog test to hobbing, and I would like to explain this. At the moment we are in the coating development, not working with complete hobs. That would take too much time because these tools can produce thousands of gear cutting. So we just use one tooth, and if you dominate this, then you can create a complete machine. And so you can detect from there how the whole machine would work. So we were able to test SpeedCore, and we could see the potential right from the beginning, because there is great potential for AMSS and carbide tools. And on the camera we have seen a test with high-speed camera, and these are sensational pictures. And not many people have seen such quality. Uwe, I would like to ask you again before we go back to Magdeburg. So why is SpeedCore that special? The special with SpeedCore hob is its cutting material itself, because it is able to support heating durability, and then you get the productivity gain, because then the cutting speed can be increased, and productivity therefore is increased too. This high-speed material is fascinating. How you can see how the chip is created, because there heat is generated, and with SpeedCore we can have a higher temperature that might be supported. So if we want to increase this cutting speed, then yes, you can do that with carbide as well. But of course, that's another cutting material with different characteristics. A SpeedCore can be used in cutting speeds exactly between HMSS and carbide. So we can reach this by getting durability, a warm durability with a balanced cobalt and molybdenum characteristic. So for the handling inside and outside in the machine, we have an advantage in comparison to carbide, and an increase of productivity. So the both of the best characteristics are combined in the new material. But with this tool, I can see it's a coated tool. Professor Kapuchev, you said before, nanosphere was one development that you did in connection with our firm. If I get back to the first statement, productivity and quality, today in such high efficiency you can only reach that with these dimensions only with coated tools. That means hobs are coated with a high quality layer, because otherwise you couldn't get that result. That's a clear statement. And I followed in Magdeburg. You were much quicker in working than we were in talking. So what about Magdeburg? Can you now tell us how SpeedCore works? Yes, we have transformed the machine. We have the same wheel, but now with a higher speed, 270 meters per minute. This process will take 24 seconds more or less. In industry it will take longer because of the handling operations of the workpiece, so we will then have 32 seconds in practice. Mr. Hertling? And the speeds of the tool, nothing will change, but the speed of production does change, as you can see in the pictures. So by a risen cutting speed with hobbing, we have a productivity increase. Thank you, Mr. Hefken. You were able to see in the second presentation it was risen 100 meters per minute, so we have shorter hopping times. And to explain to you how productivity increases, so we calculated how many pieces are made per minute with a conventional PHMSS. We can do 16 per minute. A high-speed hop can do 28 pieces per 16 minutes. So you are much quicker and your productivity raises. So we were able to show you the effectiveness and the performance of SpeedCore, and we give back to Hanover. This is an enormous increase in performance, and Uwe has shown with these two pillars the effectiveness. And could you please resume how this efficiency comes about? Yes, there's no better example. The SpeedCore hop has 50% increase in speed, so the work-piece unit relation is increasing. So as a result, the cutting material is very new and it bridges the gap between HMSS and carbide. And perhaps one commentary. The advantages of the tools were mentioned already by you. And if you have such a wonderful tool, does the user have to include many changes in processing? No. The user can maintain the process. He can use SpeedCore. The cutting speed can be adapted to his process without changing anything. I think the users will be delighted. So SpeedCore really is an extremely interesting product that we presented to you. Before finishing our presentation, I would like to ask, what do you think about the future in gear cutting? I'm not concerned. People ask me, why do we still investigate in gear cutting since we have e-mobiles already? I don't see it like this, because I think for the next decades we will still have gear cutting. The new concepts of mobility, e-mobility, hybrids, range extender, they still need gear cutting. And so we can see it's impossible to just have a range of electromobility, because we need very expensive materials, copper and rare magnetic raw materials. So there is no better system to change these moments. So I do not fear anything. Gear cutting is needed in wind energy, and there are great efforts to use gear cutting in a turbine in the air space industry. So I'm not afraid, and I'm still seeing the future of gear cutting. So we are very relaxed regarding the future, because you mentioned a very important topic. Raw materials are getting more and more expensive, and so it will be very interesting that SpeedCore is not made of carbide. So we have an opportunity to use a tool that is not that expensive. Thank you very much to Magdeburg for the presentation. Thank you, Professor Katiszewski. Thank you, Uwe Kretschmann. And who would like to form part of our talk? Everyone is invited, and in the internet we will meet again at 4 p.m. with another live presentation from Magdeburg. So I say goodbye to our visitors in the internet, and thanks for your interest here at the trade fair, and we are still available for any further talks. Thank you very much.